I think your microphone's off.
It is. Thank you. You know what? I don't know why. I have it preset ahead of time, and then for some reason when I join, it goes off. Okay, let's fix this up. Thank you for letting me know. So what I was saying is, even though this is a circles unit, we really are doing all of our work here with right triangles so far. So we should almost call this right triangles geometry instead of circle geometry. So this one's just another example of the Pythagorean theorem. Okay, now when we get to number 4, things get a little less obvious. So we're into the questions now where we have to make the right triangle ourselves. So remember, your strategy is that you can draw a radius on in order to make a right triangle if there isn't one. So that's kind of what happened here. I had to add this radius, and I know it's 7 because I know that this radius is 7. And then once I get that radius drawn on there, then I can work with this right triangle. And because of the chord property, I know that this segment and this segment are equal. And it's kind of the same thing happening over here. I have to add the radius. I know that this radius is 11.5 because this radius is 11.5. And once I have the radius on there, I've got a right triangle, and I can work with that right triangle. Now, it's hard for me to know exactly what kind of mistakes you guys might be making because I don't get to see your work. But I'm going to base this on what I've seen other years where students were just trying to make a right triangle just by adding any old line on there. So I saw things, oh, you know what? This one won't be a great one to show you, but I'm going to show you maybe on the next one. Or nope, not this one either. I'll have to show you on another one, but this whole idea of making a right triangle, you have to be adding a radius, or I suppose a diameter. When you're making that right triangle, you can't just add a random line somewhere and make a right triangle. It has to be a radius or a diameter. All right, I think we better walk our way through A and B here because these are getting trickier. And partly what's trickier is there's just so many more chords and radii and all kinds of angles going on in these circles now. So your very first job when you approach this is to write on every single measurement that you see. So for instance, this line going through the center is meeting this chord at a right angle, and that tells me that these two segments are equal. So I go ahead and I label them with the 5s. And we have that situation happening here as well. We've got a chord. We've got a line coming from the center, making a right angle. That tells us that these two are the same. Those two would be 6. And then it's about picking out a right triangle that we can work with. And there's a lot of right triangles in here. I'm going to try to point some of them out to you. There's this little guy right here. That's a right triangle. Here's a right triangle. Here's a right triangle. That one you might have missed. Here's another right triangle. So in here, we actually have 4 different right triangles that we could work with. Now, the trick is to pick out the triangle that you can actually work with. So in this one, the triangle I would like to work with is right here, because that's the triangle that includes the S. But when I pull that triangle out right in the beginning, here's what I know about that triangle. Whoops, that's not a very right angle, but here's what I would know. I know that this is 5. I know this is S. And now I'm stuck. That's a dead end triangle, because basically what I have is I've got 2 sides that I don't know. So I need to pick a triangle that I can work with. So I'm looking for a right triangle that I know both sides. And the one that I know both sides, or I should say 2 sides, is this one right here. So even though this triangle does not have S on the triangle, it is a triangle that I can work with. So that's what I did first. I pulled that triangle out over here. And I used that triangle to figure out this 7.2. Now, why that 7.2 works for me is because it's a radius. So I use this little triangle to figure out the radius. Now I can say, I can add a radius here and say this radius is also 7.2. And so then I can go ahead and work with the triangle I really want to work with, which is this one right here. So that's the work that you see over here to find S. So again, one of the strategies I used here was, if you can't find the piece you really want to find, you then just have to have this strategy of, well, what can I find? And see if it can lead you to the piece that you do need to find. Do we have any questions about A? Okay, let's take a look at B. So with B again, there's more than one right triangle in there. And there is also an isosceles triangle in there. So let me point these out to you. There's an isosceles triangle right here, because we know that this radius and this radius are the same. So we do have an isosceles triangle, but we can't do Pythagorean theorem on an isosceles triangle. And right now, when we're trying to find sides, usually it means we're going to do the Pythagorean theorem. So take a look at this side S that we want to find. It is part of this right triangle. So at first look, that's the triangle that I want to work with. And if I pull it out, here's the S. I know that these 2 segments are equal because the line from the center makes a right angle right here. So I know this is 6. But in the beginning, I do not know this length. So again, that triangle is a dead end. 2 missing sides, I can't do Pythagorean theorem there. So then I have to switch my thinking to what triangle can I work with? So I have to look for a triangle that I know a little more about. And the one that I'm going to use is this little guy right in here. This guy. So I know that this is 9 because it's going to be the same as this radius. All the radii in this circle will be 9. I'm going to pull this little triangle out. And this triangle I can work with. I know the 6 and I know the 9. And if I call this A, here's my work down here for finding A. Now, how that A is going to help me, it tells me that this section is 6.7. So if I go back to the triangle I really want to work with, this large red triangle, I can now do 9 plus 67 to get that 15.7. And I know the 6. And now I just have to do Pythagorean theorem with that larger triangle. So, you have to pick a triangle that you can work with and see what can transfer over to the triangle that you really want to work with or you need to work with. Guys, any questions there for B? All right, now this number 7, I want you to pick up on something here for future use. Anytime you are drawing your own diagram, it makes the question tougher. And in this one in particular, the hint would be if you have to draw a circle that has a chord and a diameter in it, always make them so that your diameter and your chord are parallel to each other. If you look down here, here's a different way the diagram could look. I could have my diameter here and the chord here, and I'm being asked to find this distance right here. But it just would be more confusing doing it that way. And if you always make your diagram this way, then you can make it a little bit more like how every question might feel the same rather than different. All right, so this was my original diagram right here. And then what I did was I went over here and I put in a few more details. I know that if the diameter is 28, I know the radius is 14. And the distance from the center point to the chord, that line segment's making a right angle because I've drawn it that way. Okay, so when you are drawing this, you want to make it so that that line is at a right angle. It would be pretty silly of me to say, oh, I'm going to draw it over here, or I'm going to draw it here, because then that doesn't even help me. When we're talking about the distance that the chord is from the center, we're talking about the shortest distance. So it's that perpendicular distance is what we need. So you want to draw your diagram so that it actually is going to help you with your calculation. Since it's a right angle, I know that both of those would be 9. And so I've got 9 here and 9 there. And here's the piece we're supposed to find. So what I did was I drew another radius right here so that I would have a right angle and a right triangle to work with. And then all I had to do was the Pythagorean theorem. Guys, any questions there? So remember, if you're drawing yourself a diagram, make your diameter horizontal, make your chord horizontal, and then that way you can kind of play with that same diagram every time. Now that's going to be a lot like this first question, you guys. Go to lesson 4, part 2, and go ahead and do this warm-up question. And we're also going to add in a rounding rule here as well, because we've got a lot of questions in our notes where I didn't put the rounding instructions. So little rule of thumb here, you guys, we're going to round to nearest tenth when there are no rounding instructions. All right, so I'll give you a minute here to get that one done. And then you guys, when you are finished, would you let me know in the chat? Just tell me done when you are done. Yeah, that's okay, Sarah. Come back as soon as you can. All right, guys, let's see how we did here. So lots of people done and maybe some people stuck. So let's have a look. All right, so it says our diameter is 14. Now diameters, they're not that useful. I'd rather deal with a radius. So I'm going to mark that I've got a radius of 7 and a radius of 7. We've got a chord that is 7 centimeters long. And if you look at how this diagram is given, the line from the center is making a right angle with this chord. So what I know about that chord is I know that it is bisected, which means it's cut into 2 equal parts. So each one of those little line segments is going to be 3.5. So there's step 1. Get as detailed as you can, writing on as much information as you can. And then our next step, whenever we're sitting here and it's one of those feelings of like, I just don't know where to get started, look for a right triangle. And if there isn't a right triangle, make one. Remember, to make a right triangle, you want to draw on a radius. So I want to show you the mistake that I see people making quite often with a diagram like this. They want to make the right triangle like this. So I tell everybody, look for a right triangle. If there isn't one, make a right triangle. The problem with this, putting a line like this is, well, I don't know how long that line is. So it makes this triangle without a lot of information. And I also am making an assumption that that's a right angle. So this is not a good right triangle to draw. It might not even be a right triangle. So drawing this random line that is not a radius on there does not help. So make sure when you are trying to make a right triangle that you draw on a radius. So I could draw that line here to make a right triangle. I could also draw that radius right here to make a right triangle. So the other thing that makes life a little easier for people, and not everybody really feels they need to do this, but if I take that triangle out of the circle, it just seems easier. I've got the 3.5 here. And remember, this is a radius. The reason it helps us is because we know how long the radius is. The radius is 7. And so now I can do Pythagorean theorem because I know 2 of the sides. So we're finding x. So x is this distance from the chord to the center. And x is equal to square root of 7 squared, subtract 3.5 squared. And I need you guys to probably check. My work's pretty sketchy here. I think what it says is 6.1 units. Can I see some nodding or shaking heads? And sneezing heads? Gesundheit, Helena. All right, looks good. So guys, today is our second day of chord properties. We're not learning any new properties. We're just going to continue with the practice work. Questions are going to get a little trickier today, but the more practice you do, the easier it really will get. So guys, there's kind of 2 parts to our assignment. I want you to do the textbook page questions first. So do those ones first, and then do the 3 questions that are right here in our notes. Now, when you're working out of that textbook, you guys draw the diagram on loose leaf, because working with the diagram is so much easier if you can write on it and you can draw your radius and you can label all of the line segments that you know. And your diagram will be easier to work with if it's a nice, neat diagram. So find something circular that you can trace. Use a straight edge to make your chords and line segments in there. And like always, let me know when you are stuck and I'll try to give you a hint. And keep in mind as you're working through this that tomorrow you will have a check for understanding on the chord properties. So go ahead with work time and let me know when you are stuck, please. Oh, and sorry, you see here, if we were in class, I would have had you working with the partner. It's just one of those things where if we put our brains together, it's just kind of good to bounce ideas off one another. So guys, I want you to kind of, I guess, revive your little working groups that we had in December and see if you can start maybe a FaceTime or text somebody you want to work with and kind of work through this together the best that you can.
Miss Booth, for number 12, what do you, like, I don't really understand it. Can you, like, explain?
Number 12, let's have a look.
Please. Okay.
All right, let's have a look at something crazy is going on here. How many people see a green screen?
Oh, I'm not muted.
And how is my voice there? It sounds really weird on my end. Jerry, can you give me thumbs up if things look and sound normal on your end? Oh, Jerry, we're good? Okay, okay. Let's go. Here's number 12. So a circle has a diameter of 14 centimeters. Which of the following measures could be lengths of chords in this circle? Justify your answers. How could you check your answers? Now, you don't have to have like a detailed diagram to really look at this, but I want to just give you a hint here that the diameter, remember, is a special chord that goes right through the center, right at the longest or the widest part of the circle. So think about all the other chords that you could put in here. Let's say that chord, that one, that one. Guys, what do we know about the diameter compared to all of these other chords? What does your gut, your common sense tell you? Charlie B, what do you think?
It's the biggest chord?
It is. Because the diameter goes through at the widest part of the circle. So when you go to think about the other chords, if the diameter is 14, all of the chords in that circle have to be 14 or less. So on that one, when it says, which of the following measures could be lengths? Well, this could be the length of a chord. So could this. And this one as well, because remember that the diameter is a chord, but we could not have a chord that is 18 centimeters because it would go outside of the circle if it was 18 centimeters. And then for B, for each possible length you identified in part A, determine how far the chord is from the center of the circle. So this is that diagram that I talked about earlier when we were going through our worksheet. You're going to have, and remember it's going to be easier for your brain to visualize if it really does look like a circle. And remember, you're going to draw it like this, parallel. And you're always going to make sure that when we talk about how far is it from the center, that we're talking about the perpendicular distance. So I'm not talking about this distance. I want to know how far this chord is from the center point then I need to know this distance right here. So for each one of these, 5 centimeters, 9 centimeters, and 14 centimeters, you already know that's the same as the diameter. So I guess we could say that it is 0 centimeters away because it is the diameter. So you really just have to do a 5 centimeter and an 18 centimeter one. And now it turns out to be a question much like the ones we've seen, where the missing distance is that X. So that should be enough to get you going there on 12, I think. Do you guys have any other ones you want to do while I've got your attention?
Yeah, it's good, thanks.
Okay. Let me know when you're stuck, guys.
Miss Booth,
Yes.
do we have a test today, or is that?
No, we have our next assessment is tomorrow. We have a check for understanding.
Okay,
then-
because it said covers lesson 3 and 4 surface area.
Yeah, yesterday after I kicked you out, we were talking about the new plan.
Okay,
Okay, so check on all the dates for that stuff is on Google Classroom under the Stream tab.
okay.
Okay. Hey team, how are we doing out there? Is anybody done the assignment already? Give me a thumbs up, please, if you are done. Okay, so it looks like most people have a little more to do. Here's just a little bit of information for you. We are doing, and of course you can check on the stream. As I said earlier, all the dates for our assessment are up on the stream. So tomorrow we will have a check for understanding on this chord property that we're working with. And Thursday is a bigger assessment, a quiz that will cover lesson 3, 4, and 5. So basically all of the properties that we've done so far. Tomorrow we'll be covering lesson 5, as well as that check for understanding. What else? Oh, Ethan, I'm not sure if you saw it in the chat. Ethan, please check your email so that you get some information about writing the exam that you missed before we were, or actually, I guess after you were quarantining. And I think that is it. Did you guys know tomorrow is Wear a Hat for Mental Health Day? So I want to see lots of hats out there, you guys. And that's it. I'm going to stay here till the last person leaves, but you are welcome to go if your work's going smoothly. So stay strong, be kind, and stay home, everybody. Let's get the numbers down. Miss you guys. See you tomorrow. Oh, Katie, you're back. Just in time.
Miss Booth,
Yeah.
Katie's computer won't let her leave.
First, it won't let her in and kicks her out, and now she can't leave.
Yeah.
If we don't have any questions or anything, I can just end the meeting from my side.
Okay. Thank
Okay.
you.
See you guys tomorrow.
Bye.
Bye.